when does this thing hit the ground again? Okay, and we've already done something like this. I think those two questions are harder. Okay, finding the vertex and finding when it's at 160. The next thing is they're going to say, when does this thing return to the ground? When they say return to the ground, they're implying what your y value should be. Okay, what y value should I have, or h of t value should I have when I hit the ground? Zero. Okay, so they're saying instead of this being 160, it's now 0. Okay, and now we just do the quadratic formula again. Opposite of b plus or minus b squared minus 4 times a times c now at 100 all over negative 32. That'll be my time. Okay. Now, one of those time values that they give you back, I'm going to just, for the sake of time here, I'm going to go to the next slide and see if they actually do this. Okay. When we go through and do this, we should get 6.04 for one of these t values. And that makes sense, right? But look at my graph over there. Where does the other t value, where does this other side of our parabola, where does it cross the t-axis? What type of numbers are there? Negative. Okay? So you get a negative time, which mathematically is fine because the numbers in the equation doesn't really know that I'm dealing with time, right? It doesn't really know that, hey, he only wants the positive answers back. Okay? So you have to distinguish positive answers from negative answers when we're talking about time. Okay? So the only time this thing comes back to 0 is at that 6.04, which is one of those quantities when you evaluate that. Okay? The other one's going to be a negative something. Okay? And the other one is going to be, just kind of thinking about this, if this is that time is 6.04, and the vertex was at 2.5, okay? We should be able to do subtraction there, find out what that difference is. 6.04 minus 2.5, it gives me 3.54. Does that make sense? So the distance, what I just found, is that distance right there between the axis of symmetry for a parabola and one of the x-intercepts. And it's that distance that is green is 3.54. So can I take and subtract from this number 3.54 and find that other x-intercept over there? Okay. So when I take 2.5 minus 3.54, these two time values, without even evaluating this, I now know that these two time values were 6.04 and negative 1.04. That one we don't count because it's a negative time, right? Okay. That's kind of how we deal with those types of functions, those types of real-life situations with some algebra. And this is stuff that you might do this in physics when you guys shoot off your rockets. Okay, at some point you'll make rockets, and maybe, I don't know, maybe Mr. C used to make rockets with his class. I don't know if you guys do that lab still. But they would calculate this stuff. Okay. Anybody that goes into the military and works with ballistics or anything understands this math. Okay. And understands. We're just skimming the surface, but they do a whole lot more with this stuff. Because we would like to be able to shoot down a ballistic from North Korea at some point, right? Okay. So it'd be nice to make sure that those people that are doing this stuff understand this physics and understand this math to be able to do that. What I want to show you guys is how to use your calculator to do this. Okay, because you're seeing here that that's a lot of what's going on in the PowerPoint. What I want you guys to do, get your calculators out, and you're just going to go to y equals. Throughout the year, one of the goals that I have is for you to become a little bit more efficient with your calculator. Not necessarily let your calculator do the work for you, but to maybe enhance your work, to provide some insight to you that maybe you didn't have prior to using your calculator. So in y1, all I want you to do is type in negative 16. Now we don't have t's here, so we're going to use x, which is fine. Squared plus 80x plus then 100. Okay? Now if we graph this, and most of your graphs are going to be initially standard view, which they start you from like negative 10 to positive 10 on the y-axis and negative 10 to positive 10 on the x-axis. Okay? Obviously that doesn't get much of our picture in there, right? So we got to go mess with the window. Alright, so I need you guys to click on the window key. Okay. Now, we've already done some of the work here, and sometimes when you use your calculator, maybe you haven't already done all the preliminary handwork, like we've done on the whiteboard. So sometimes finding your window and finding a good window might be kind of trial and error, where you adjust the numbers, you go back to the graph, and you get the whole graph in, yes or no. If it's no, go back to the window, readjust, remanipulate the numbers, and then see. Does that kind of make sense? So it's back and forth sometimes. But we've already done a lot of this, so let's say the x minimum. I'm really not interested in anything to the left of the x-axis, or sorry, the y-axis, right? So let's just make our x minimum either 0, or maybe, I don't know, -1 or -2 or something like that. Our x maximum now, what was our vertex's height at? Or sorry, what was the vertex's, not the vertex, the x-intercept, what was its largest value? Say again? Careful, I misspoke. What's these values? What's the largest x value that we had? It was this one, right? 6.04? Okay. So let's make our x maximum a little bit bigger than that. I'm just going to go to 8. Okay. X scale, all the scale means is this is how many kind of markings you're going to see on your axes. So you'll see 9 markings if we leave that at 1, right? I can change it to 2 and say it's going to put a mark every 2, and so forth. I think I can leave that at 1. Now my y minimum, okay? My y minimum I don't care about. It's not going to be negative. All right, y values, I'm not interested in negative y values, right? But what we want to make sure is that when we go through our calculator, you see this stuff over here, these numbers? We don't want those numbers to show up on top of our x-axis, so we've got to push our x-axis up a little bit. So I'm just going to say my y minimum, I'm going to leave it at -10 and see if that works. Okay? But my y maximum, what was the maximum of the vertex? What was that height? 200. So I've got to change this to a pretty large number. I'm going to go to 220. Okay? But now my y scale is 1. So what it's saying is that between -10 and 220, I need a mark for every integer between those. That's kind of unrealistic, isn't it? Okay? So let's say that we put, let's just go by 20s. Okay? And now we'll graph it. And that looks somewhat realistic, doesn't it? Okay? Now understand what this means. Because of the scales that we use. That's 0, that marking is 1, that marking is 2, that marking is 3, 4, 5, 6. Now on the y-axis, they're not going by 1s, right? We chose to go by 20. So 20, 40, 60, 80, 100, which is mimicking then that place that we stood on the y-axis and threw that ball. Okay? The next thing we would want to do, if I want to see when this thing, I'll finish this video and do the calculator portion during third period today. About fell down. And put that on the website so you know how to use your calculator for the homework. Okay? Just finished